You know, in cricket, just like in life, it's the basics that build champions. You can't score a century without learning how to hold the bat right. You can't bowl a perfect line without mastering your run-up. And when it comes to electronics, it's no different. Every advanced system, every breakthrough innovation, starts with one simple thing: understanding the fundamentals. Today, we're talking about one of the most important building blocks in electronics, the basic LED blinking circuit using a 555 timer. Now, this isn't flashy. It's not going to impress the crowd right away. But trust me, this little setup is like your first net session. It teaches timing, it teaches rhythm, it teaches control, and just like a cricketer builds confidence from that first clean cover drive, you build confidence in electronics from your first blinking LED. Don't skip this, don't rush it, because champions aren't built on shortcuts. They're built on repetition, consistency, and showing up even when no one's watching. Let's break this down. Let's respect the process. Let's learn how this humble 555 timer can teach us the power of precision and the beauty of doing the basics well. When you walk out onto the cricket field, no one starts with a 6 over long on or a yorker that uproots the stumps. You start with stance, with grip, with footwork. You start with the basics, and for any young cricketer, you learn early on that if you don't respect those basics, the game humbles you. That same principle applies to electronics, and more specifically to building a simple LED blinking circuit with a 555 timer. It may look simple on the surface, just a light flashing on and off, but don't be fooled. This tiny project holds the same weight as that first net session with a bat in hand. It's your foundation, and if you build it strong, everything else stands on it. When you first begin learning electronics, it's tempting to skip ahead. Just like a young cricketer wants to practice reverse sweeps and helicopter shots before mastering the straight drive, students want to jump into microcontrollers, wireless systems, and advanced automation. But the truth is, without grounding in the fundamentals, all that ambition turns to frustration. The LED blinking circuit is your front, foot defense. It's your grip alignment. It teaches you patience, rhythm, timing, and confidence. You learn how current flows, how components interact, how voltage and resistance work together. These aren't just numbers on a multimeter. They're lessons in structure, in discipline, and in humility. Think about it. The 555 timer itself is a marvel, designed in the 1970s and still relevant today. That's not an accident. That's design done right. Just like how a solid batting technique from the 1960s still applies in today's game, the 555 timer hasn't lost its place. Because fundamentals don't age, they endure. When you use it in a stable mode to create a blinking LED, you're not just wiring components, you're learning pulse generation, you're understanding how frequency and duty cycle work. You're beginning to see how something constant and repetitive can become powerful and dynamic. That's exactly what training is in any sport. It's the repetition of basics until they become instinct. When I was working on my game, there were days I didn't want to go to nets. Days when I felt like the basics were boring, but those were the days that built me, because champions are made in silence in those unseen hours where you commit to doing the small things right. It's the same when you're soldering your first circuit or adjusting the resistor value to change the blink rate. You might not feel like you're doing much, but you're building discipline. You're learning to follow through. You're laying the track for everything that comes after, and this is where most people miss it. They think this is too simple to matter. Just one LED, just one timer, but think again. That one LED teaches you how to read a datasheet, how to connect power and ground correctly, how to place components on a breadboard, how to debug when it doesn't work, how to troubleshoot with a multimeter. Every skill you need for complex projects, every single one, starts right here. That's why it's not just about knowledge, it's about mindset, about treating the basics with the respect they deserve. because when you do, you develop habits that carry you forward when the pressure's on. Imagine you're in a match situation. The ball's swinging under lights, and your team needs someone to hold the line. That's not the time to guess or experiment. That's when you fall back on what you know, what you've trained. It's the same in engineering. When your circuit isn't working, when a client deadline looms, you don't want shaky fundamentals. You want to be the kind of person who's built from the ground up, who's seen the problem before, solved it before, and kept their composure through it all. Let me tell you something else. The LED blinking circuit is more than a technical exercise. It's a character check. Can you finish what you started? Can you follow the instructions carefully and not rush? Can you stick with it when the LED doesn't blink the first time and you don't know why? That right there is the grind. That's the mental toughness that separates the average from the elite, not just in sport, not just in academics, but in life. It's easy to get excited by big ideas. It takes grit to master the small ones. You'll notice something when you take this circuit seriously. You'll begin to see the beauty in simplicity. You'll realize that minimalism isn't laziness, it's efficiency. That great design isn't about how many features you pack in. It's about how well the essentials perform. That's a lesson straight out of cricket. The best innings aren't the flashiest. They're the ones built with good judgment, solid technique, and calm execution under pressure. That's what this project teaches you, and once you've built it once, you'll build it again, you'll tweak it, change resistor values, switch the LED color, add a capacitor, try to push the timing limits. That curiosity, that creative problem solving comes from knowing your base is solid, and don't be surprised if your first try doesn't work. That's part of the process. That's like getting bowled first ball in the nets. It stings, but you walk back, take a breath, adjust, and go again. Every mistake you make teaches you something valuable. Wrong pin connection. Now you understand the IC layout. Wrong resistor value. Now you grasp Ohm's law better. LED not lighting up. Maybe polarity matters after all. These aren't failures. They're opportunities to deepen your understanding, to test your resilience, and to build your problem-solving mindset. I've been in games where everything goes wrong. The pitch is unpredictable, the opposition is aggressive, and confidence is low. And in those moments, what gets you through isn't talent, it's training. It's the reps you've put in, the discipline you've developed. That's why I don't just respect the basics. I rely on them. And if you treat this LED blinking circuit the same way, you'll start to see how even a tiny light flashing on and off can teach you about logic, structure, and perseverance. Look at any expert, anyone who's truly great at what they do, and you'll find someone who has mastered the basics, not just once, not just as a checkbox, but again and again with full focus. Because mastery isn't about doing different things. It's about doing the same thing better each time. And that's what this project gives you a chance to do. To revisit the same idea, improve it, deepen it, and eventually teach it to someone else. The temptation to move fast is always there, to impress people, to build something big. But real power doesn't come from rushing, it comes from rooting. The deeper your roots, the higher you can grow. That's why the first time you see your LED blink, it should fill you with pride, because that blink means you understand something. It means you've built something that works, and that's the first step on a path that leads to far greater things. You'll be surprised how far this one circuit can take you. It's the gateway to oscillators, timers, pulse, width modulation, motor control, sensor integration, you name it. But none of those are possible if you don't first learn this. Just like you can't survive a test match if you can't leave a good ball. The basics are not optional, they're foundational. So, whether you're building your first project or coaching someone else through it, remember this: greatness starts small, mastery starts simple, and the LED that blinks in front of you today might just be the spark that ignites your whole future tomorrow. In both cricket and engineering, timing is not just a detail, it's everything. It's the difference between playing a cover drive too early and getting caught, or waiting that extra split second and sending the ball racing through the gap. Timing defines outcomes, builds rhythm, and separates chaos from control. And when you build a basic LED blinking circuit using a 555 timer, you're not just watching a light flash, you're witnessing a lesson in precision, a real-world expression of timing in action. Every blink, every pause, every interval is governed by components working in perfect harmony, and if you take the time to understand that, you're learning far more than electronics. You're learning how precision shapes purpose. When you configure a 555 timer in a stable mode to make an LED blink, what you're actually doing is creating a square wave, a series of on and off pulses with specific time durations, and those durations are controlled by resistors and capacitors. One slight change in resistance or capacitance, and your blink rate changes. That's timing, that's precision. It's like adjusting your bat swing by a fraction of a second. It makes all the difference. One mistimed shot can end an innings. One miscalculated resistor can stall your circuit. The parallel is clear, and the lesson is deep. Timing isn't accidental, it's engineered, it's deliberate, it's practiced. And the beauty of the 555 timer is that it shows you this principle without saying a word. It doesn't need to shout to teach you. The LED blinks calmly, consistently, with rhythm you can see and measure. It becomes your feedback loop. You're not just learning from books or theory. You're learning through experience. You're seeing how electrical charge builds up in a capacitor, how the voltage reaches a threshold, how the timer reacts, resets, and triggers again. This is time in motion. You're learning how delay is not a problem but a design, how even in electronics waiting has a purpose. In the game of cricket, every batsman learns to wait for the ball. You don't just swing because it's coming at you. You wait for the right moment, for the right length, the right pace. You train your body to respond only when the time is right. It's the same when you build a timing circuit. You could slap components together and hope it works. Or you could calculate the time constant. Choose your resistor and capacitor values carefully. Place them with intent. That's what separates the amateur from the professional. Not talent, but timing. Not guesswork, but design. The LED doesn't care if you're in a rush. It won't blink faster unless you've earned it, unless you've adjusted the resistance, swapped out a capacitor, and truly understood what you're doing. That discipline is priceless because it trains your mind to be precise, to be thoughtful, and to value the power of small adjustments. In cricket, that might mean opening the face of the bat a little to guide the ball. In electronics, it might mean going from 470F to 220F to reduce your blink interval. Both are acts of control, not instinct, of knowledge, not reaction. Once you begin to appreciate timing in your circuit, you'll start to see timing everywhere. You'll realize that your entire world runs on pulse and delay. Your phone, your computer, your car, they're all orchestrated by timing mechanisms, from crystal oscillators to timers to microcontrollers. And they all began with something as simple as what you're building now. That blinking LED is not small, it's a window into how time shapes function. And when you see it with that lens, you realize how critical it is to get it right. Some people think precision is restrictive, that being exact removes creativity, but that's not true. Precision is freedom. When you know exactly how your circuit behaves, you gain the freedom to innovate. When you can trust your timing, you can build on it. You can add sensors, motors, displays, but only because you've established a solid foundation. That's why the 555 timer is so popular. It's dependable. It gives you control. It reacts when and how you want it to. That predictability is your platform for creativity, and let's be honest, it takes patience to get it right. Your first attempt may result in a light that doesn't blink, or one that blinks erratically. That's not failure, that's the process. That's the net session where you edge 10 deliveries in a row. It's where you check your grip, your head position, your footwork. In electronics, you check your wiring, your values, your power supply. And when it finally works, when that LED starts blinking exactly as expected, that's your sweetly timed boundary. That's the reward for staying with it. You'll also learn how to think in cycles, how timing isn't just about one action, but about repeated actions over time. The blink pattern becomes your clock, and clocks are the heartbeat of digital systems. You start to see how timing pulses coordinate operations, how synchronization is everything. In a way, that LED is doing what your body does when you're batting. It's responding to internal cues and external conditions with consistency and rhythm. And when your timing is off, your whole performance suffers. That's not just metaphor, that's reality. Another important aspect is this: timing teaches respect. In the circuit, the capacitor needs time to charge. If you don't give it that time, the system won't work. You have to wait. You have to trust the process, and that's the same in life. You can't rush growth. You can't force outcomes. You have to work with the elements, not against them. Whether it's a circuit or a season of training, timing reminds you that things happen when they're ready, not when you're impatient. You also learn the cost of poor timing. Use the wrong values, and your LED may blink too fast to be useful, or too slow to be noticed. Just like a mistimed shot in cricket can cost you your wicket, mistimed execution in electronics can render your whole design pointless, and so you learn to plan better, to test more, to observe closely. That's not just engineering, that's maturity, that's awareness, and that's what separates those who tinker from those who build. As you experiment, you'll start to predict what will happen before it happens. You'll start thinking in units of time, milliseconds, seconds, and you'll begin to feel the rhythm of your circuit. That's the moment when you stop being just a student and start becoming an engineer, because now you're not reacting to problems, you're anticipating them. That's what good batsmen do. They don't wait to see what the bowler does. They read it early and respond with clarity. That clarity only comes from time spent mastering timing, and once you have timing under control, you gain authority. You become the one setting the pace. In cricket, that might mean taking control of the scoreboard, dictating the field. In electronics, it means your circuit becomes dependable, repeatable, trusted. You can say with confidence what it will do and when. That's the kind of confidence every builder, every leader, and every player strives for. Eventually, you'll look back on this small project and realize how much it taught you. It wasn't just about an LED blinking. It was about understanding that delay has purpose, that intervals matter, that every second is shaped by design. You'll begin to notice that even your thinking becomes more timed, less impulsive, more strategic. And that kind of thinking pays off whether you're facing a bowler at 140 kilometers per hour or bugging a circuit at 1 a.m. You don't need advanced systems to learn deep truths. Sometimes all it takes is one timer, one capacitor, 2 resistors, and a humble LED. Because when you slow down and pay attention, the simplest things can teach you the most. Timing isn't glamorous, but it's essential. It's the heartbeat behind every success, every breakthrough, every match-winning moment. And just like every great cricketer learns to trust their timing, every great builder must learn to trust theirs. You don't rush, you don't guess, you observe, you adjust, you learn the flow. And then, when the moment is right, when your components are aligned and your design is sound, you let it run, you let it blink, you let it prove that timing, when respected, becomes power. There's a truth that holds steady across disciplines. Whether you're stepping onto the cricket pitch or sitting down at your workbench with a breadboard and a handful of components, consistency builds competence, and competence builds confidence. That's not a slogan, it's a process, and when you're building a basic LED blinking circuit using a 555 timer, you're entering into a discipline of repetition. You're doing something simple, but you're doing it again and again until it becomes second nature. That repetitive process, often overlooked and undervalued, is what sharpens your skills and lays the groundwork for everything greater that you'll build in the future. In cricket, no one starts off confident. Not even the greats. Confidence isn't something you walk onto the field with, it's something you earn. Over time, through effort, through drills, through repeating the same stroke over and over until your body knows it better than your mind does. And when it comes to electronics, and especially in the case of a fundamental project like the 555 timer LED circuit, you're doing the same thing. You're not just learning how to wire a chip and a diode. You're training your hands, your eyes, your thinking. You're making consistency your ally. When you build this circuit the first time, it may feel exciting, but the real growth comes when you build it a second time, and a third, and then start tweaking values and seeing how timing changes. You move a wire, replace a capacitor, try a different power source. Suddenly, what was once mysterious becomes manageable. What was once frustrating becomes familiar. This is the quiet transformation that repetition brings. Just as a batter learns to play the same shot against pace, spin, swing, and bound, repetition in electronics trains you to stay composed in the face of variation. You begin to recognize patterns. You stop guessing. You know instinctively how the timer responds when you swap a 1K resistor for a 10K one. You no longer wonder what will happen. You predict it, you expect it. That's what real learning looks like, and it's not flashy. It's not immediate, but it is powerful, and it sticks. The people who succeed in anything, whether it's engineering, sport, or business, are not those who do one big thing right, but those who do the small things right every single time. Let's talk about what consistency actually trains in you. First, it develops muscle memory. In cricket, your backlift, your footwork, your follow-through, all of it becomes automatic through repetition. In electronics, placing components, identifying pins, measuring voltages, recognizing correct orientation, these become second nature through repeated exposure. You're not wasting time looking things up anymore. You're flowing through the process. That flow state is where real confidence begins to grow, because you're not just acting, you're understanding. Second, consistency teaches you to troubleshoot calmly. The first time your LED doesn't blink, you may feel frustrated. Maybe you missed a connection or used the wrong resistor. But if you've built the same circuit 10 times, you know where to look. You start developing a mental checklist. Power supply, check. Pin configuration, check. Resistor value, check. Capacitor polarity, check. This kind of structured thinking is exactly what's needed when you face bigger and more complex systems. Without consistency, you panic. With it, you problem solve. Third, repetition sharpens your focus. When you're doing the same circuit over and over, your mind starts noticing details it missed the first time. You start to ask deeper questions. Why does this resistor value slow the blink rate? How does the capacitor charge curve affect the timing cycle? What exactly is happening inside the 555 timer's internal flip-flop circuitry? That curiosity doesn't arise by accident. It's born from familiarity, and familiarity only comes through doing. Not once, but repeatedly. You also begin to respect the craft more. You realize that even the simplest circuits deserve precision. That a misplaced wire can ruin functionality. That a wrongly oriented LED won't light up no matter how much you want it to. It's in those repetitive moments where you pause, double, check, and correct your work that you begin developing excellence. Not perfection, but excellence. A deep desire to do the job right, not just get it done. That's a mindset that carries over into every area of life. One of the biggest lies we're told is that confidence comes from success. That's not true. Confidence comes from preparation, from knowing you've put in the work, from knowing that you've practiced enough to handle whatever comes. In sport, it's the player who's faced 1-0 balls in the nets who can walk out calmly against a world-class bowler. In engineering, it's the student who's soldered dozens of circuits and studied failures who can approach a complex system with steady hands. Confidence is earned, not assumed, and it's earned through consistency. Think about this. The 555 timer has been around for over 50 years. It's outlasted trends, surpassed expectations, and proven itself reliable across generations of engineers. That's the kind of legacy consistency builds. Not just performance once, but dependable performance again and again. Your blinking LED circuit may feel small, but in building it, you're participating in a tradition of makers who understand the value of getting it right every single time. That's not nostalgia, it's wisdom, and you're stepping into that wisdom with each repetition. You'll also start to feel less overwhelmed by complexity. When you begin, everything feels new and uncertain. But as you repeat the process, placing the timer, wiring the resistors, setting up the capacitor, you begin to see how complexity is really just layers of simplicity done well. That's a life principle worth holding on to. Whether you're managing a team, building a product, or chasing a goal, if you do the basics with consistency, everything else becomes possible. The blinking LED becomes a symbol of this truth. That steady beats flashy every time. Sometimes you'll hit setbacks. A component may burn out. A wire may break. A circuit may short unexpectedly. But if you've built the circuit before, those setbacks don't shake you. They may slow you, but they won't stop you. That resilience is forged through consistent practice. Every time you push through the mundane task of checking your setup, you're building stamina. That's what carries you through bigger failures. That's what gives you the endurance to stay in the game when others quit, and don't underestimate the power of mastering one thing deeply. In a world obsessed with doing everything, there's strength in doing one thing really well. If you can build a 555 timer LED circuit in your sleep, if you know how to tweak it, optimize it, debug it, you've gained more than a skill, you've gained mastery, and mastery is transferable. Once you know what it feels like to truly understand something, you can apply that approach to anything else. That's how you grow, not by doing more, but by doing better. Over time, you'll start to teach others. Maybe a classmate, a friend, or a younger sibling, and when you do, you'll realize how much you've learned. Not from one big lesson, but from 100 small repetitions. You'll see that what once confused you now flows out of you with clarity. That's the fruit of consistency. That's the confidence that no textbook alone can give you. And here's another thing. It's not just about the circuit. It's about what you become while building it. You become patient. You become detail-oriented. You become disciplined, and all of that spills over into every other part of life. You manage your time better. You face challenges with a calmer spirit. You start believing in your ability to figure things out. That belief doesn't come from hype. It comes from history. Your history of showing up, putting in the work, and growing through the process. Repetition also builds ownership. The more you build this circuit, the more it becomes yours. Not just a project you copied from a diagram, but something you understand, something you've refined, something you've made better through your own effort. And ownership builds pride, not in a boastful way, but in a way that fuels further growth. You want to learn more, build more, experiment more, not because you have to, but because you're invested. Eventually, you'll look back and smile at the early versions of your blinking LED. You'll remember how long it took to get it working the first time, how unsure you felt. And you'll compare that to where you are now, confident, calm, competent. That's the journey repetition takes you on, from hesitation to fluency, from confusion to clarity, from trying to thriving. So when someone tells you that building the same circuit over and over is boring, you'll know better. You'll know that every repetition is a rep in your training. Every rebuild is another step toward mastery. And every blink of that LED is a reminder that you're getting sharper, stronger, and more confident, one consistent action at a time.